Imagine standing next to a block of stone so tall it blocks out the sun. You crane your neck back. The stone is still going. It weighs more than a blue whale. More than 2 blue whales, and the people who moved it had no cranes, no steel cables, no engines, just rope, water, and each other. Scientists at Binghamton University say they have finally proved how Easter Island's stone giants moved themselves across the island without wheels, without rollers, and without hundreds of men dragging them flat on the ground. For generations, that dragging theory was the answer. Horizontal, slow, exhausting. Log rollers under a sledge, ropes pulling forward, an army of workers inching a statue across volcanic rock. That was what the textbooks said. That was what tour guides repeated. That was the settled version. Carl Lipo, a professor of anthropology at Binghamton University, and Terry Hunt at the University of Arizona looked at 962 moai. Not a sample, not a selection. Every single one that has ever been catalogued. And what they found in the design of those statues, published in the Journal of Archaeological Science in October 2025, broke the settled version apart. Stay with me, because once you see it, the stones never look the same again. The walking stone. Look at the moai that are still standing along Easter Island's ancient roads, not the ones on the platforms at the coast, the ones in transit, the road moai. They share something the platform statues don't: a wide, flat, D-shaped base, a forward lean-off between 5 and 15 degrees, tilted toward the direction of travel. For a century, archaeologists assumed those features were rough work, unfinished, not yet trimmed to the final shape. Lipo and Hunt's 2025 study shows they were not unfinished, they were engineered. That D-shaped base and that forward lean are what allow a statue to rock, side to side, left, right, left, the same motion you use when you shuffle a heavy refrigerator across a kitchen floor. Except the refrigerator weighs 4.35 tons and you are doing it across an island. The team built a replica, same proportions, same base shape, same forward lean, 18 people, 3 rope teams, 1 team on each side, pulling alternately to create the rocking motion. 1 team at the back, controlling the lean so the statue doesn't tip forward and fall. They moved it 100 meters in 40 minutes. 18 people, 100 meters, 40 minutes. The roads on Easter Island are not random paths. They are slightly convex, raised in the middle, which prevents the base of a rocking statue from catching on the edges. The roads were built for the walking method. The statues were shaped for the walking method. The whole system was designed around a physics principle that any engineer today would recognize immediately, and that a civilization with no written language, no wheel, and no metal tools worked out on a remote island in the South Pacific sometime around 1200 CE. But here's where it gets complicated. The 18-person experiment used a 4.35-ton replica. The heaviest moai ever moved to a platform weighed 86 tons. The walking method is proven for small statues. For the giants, the physics gets harder, and nobody has tested it at that scale. The road moai are proof of concept. They are not proof of completion. The man with the jar, roughly 3,000 years before Easter Island's builders were rocking their statues down ancient roads, an Egyptian provincial governor named Jehuti-Hotep commissioned a statue of himself. It stood 60 tons, not 60 pounds, not 600 kilograms, 60 metric tons of carved stone, shaped in a quarry and needing to travel across desert to its final resting place. The transport of that statue was recorded not in a modern study, not in an excavation report, in a painting on the wall of Jehuti-Hotep's tomb at Deir el-Bersha, painted around 1900 BC. The painting shows 172 men. They are arranged in 4 columns, pulling ropes attached to a wooden sledge. The statue sits upright on the sledge, and at the front, standing directly ahead of the sledge's runners, is a single worker. He is pouring something from a jar onto the ground in front of the sledge. Egyptologists looked at that painting for most of the 20th century and called the jar pouring ceremonial. A ritual gesture, symbolic. It was not until 2014 that physicist Daniel Bohn at the University of Amsterdam tested what happens when you add the right amount of water to desert sand ahead of a sledge. The answer: the sand grains bind together, the surface stiffens, friction drops by half. One worker with a jar, half the friction. That is not ceremony. That is the oldest recorded act of lubrication engineering in human history, painted on a tomb wall 3,900 years ago, misread as decoration for over a century. 172 men moving 60 tons was already a feat. With the right amount of water on the sand in front of the sledge, it was a manageable one. The stone that never left. Jehuti-Hotep's 60-ton statue was not the most ambitious thing the Egyptians ever attempted. It wasn't even close. Around 1473 BC, Queen Hatshepsut ordered a single stone cut from the granite quarry at Aswan. The plan was for an obelisk 42 meters tall. That is taller than a 12-story building. The estimated weight between 1,168 and 1,200 tons, the heaviest single stone monument ever attempted by any civilization in recorded history. The workers began cutting it from the bedrock. They used dolerite pounding balls, round stones harder than granite, and they hammered them against the rock face over and over, wearing the granite down millimeter by millimeter. The marks are still there. You can see them today. Somewhere during the cutting, a crack appeared in the granite, not a crack that could be worked around, a crack that ran through the stone and made the whole project impossible. The workers put down their tools. The stone stayed in the quarry. It is still there, still attached to the bedrock at Aswan, still showing the pounding ball marks from 3,500 years ago, still 42 meters long. It is called the unfinished obelisk, and it is the most useful engineering document ancient Egypt left behind because it shows exactly how the cutting was done, frozen at the moment it failed. The obelisks that were completed, the ones that were eventually raised, are a separate engineering problem. Moving a 1,000-ton stone from a quarry to a building site, then standing it upright at the end of the journey, is a question that engineers and archaeologists are still genuinely debating. The cutting method is solved. The transport and erection of the very largest stones are not. The Welsh quarry. Move west now, move forward in time, or rather backward, to about 3000 BC, to a rocky outcrop in the Preseli Hills of Wales called Craig Rossi Felin. On July 23, 2025, Professor Richard Bevins of the Department of Geography and Earth Sciences at Aberystwyth University published a study in the Journal of Archaeological Science reports. Using mineralogical, petrographic and geochemical analysis, his team matched a specific boulder at Stonehenge, the Newall boulder, to the rhyolite group C rock formation at Craig Rossi Felin. The distance from Craig Rossi Felin to Stonehenge is over 200 kilometers. For most of the 20th century, the leading alternative theory was that glaciers did the work. That ice sheets during the last glacial period picked up the Welsh bluestones and deposited them closer to Salisbury Plain, where Neolithic people found them and moved them the rest of the way. It was a plausible theory. It reduced the human transport problem to a manageable scale. Bevins's 2025 study closed that theory down. The geochemical match is too precise. The stone at Stonehenge came from a specific spot at Craig Rossi Felin. And at that quarry, researchers found stone wedges in situ. Wedges with a geochemical composition different from the surrounding rock, meaning they were brought to the site. Neolithic people brought tools to that quarry, drove wedges into the rock face, and extracted blocks of bluestone on purpose. A 4-ton block of Welsh bluestone, extracted with stone wedges, then moved 200 kilometers across rivers, hills, and the Bristol Channel to Salisbury Plain. Without wheels, without draft animals large enough to pull a load that heavy, without metal tools of any kind, the glacial theory is gone. The human transport is confirmed. How those specific people moved those specific stones across that specific terrain is still an open question, and no experiment has yet replicated the full crossing. The River Road. Across the Atlantic, in the lowland forests of what is now the Mexican Gulf Coast, a civilization was solving the same problem with a different geography and a different answer. Between roughly 1200 and 900 BC, the Olmec people at San Lorenzo were carving colossal heads from basalt. 17 of them have been confirmed. The smallest weighs 6 tons, the largest weighs 44 tons. They stand between 1.47 and 3.4 meters tall. Every single one of them was carved from basalt, quarried at Cerro Sintepec in the Tuxtla Mountains, approximately 80 kilometers away. The Olmec had no wheels, no draft animals capable of pulling heavy loads. The largest animal available to them was essentially a deer, and they were moving 44-ton boulders across 80 kilometers of tropical lowland. The answer was the Coatzacoalcos River. The working theory, supported by the landscape and the logistics, is that the basalt boulders were dragged overland to the nearest navigable water, then loaded onto wooden rafts and floated upriver to San Lorenzo. Moving a 44-ton stone on water requires far less force than moving it on land. Water does the friction work. The river becomes the road. What happened after the heads arrived is a separate mystery. Around 900 BC, most of the colossal heads at San Lorenzo were deliberately smashed. Faces were defaced, some were buried. The scale of the destruction suggests it was intentional and organized, not the result of invasion or accident. Nobody knows why. The heads that survived did so because they were buried before the destruction reached them, or because they were at sites that were abandoned first. The engineering that moved them is partially understood. The reason they were destroyed is not. The Ice Road. 500 years ago, a document was written in China that nobody outside a small circle of historians paid much attention to for centuries. It described how workers moved a single stone to the construction site of the Forbidden City in Beijing. The stone was 9.6 meters long, 3.2 meters wide, and 1.6 meters deep. It weighed 123 tons. Professor Zhang Li of the University of Science and Technology Beijing translated that document and, with Princeton mechanical engineer Howard Stone, published an analysis in the Proceedings of the National Academy of Sciences in 2013. What the document described was this: in the winter of 1557, workers slid the 123-ton stone 70 kilometers to the Forbidden City. Not on rollers, not on a sledge dragged across bare ground. On ice. Workers dug wells every 500 meters along the route. Through the night, they poured water onto the ground ahead of the stone. By morning, the water had frozen into a smooth ice road. The stone, on a wooden sledge, moved across the ice with almost no friction. Lee and Stone ran the calculations. On dry ground, moving a 123-ton stone 70 kilometers requires approximately 1,537 men. On a water-lubricated ice road, the same stone, the same distance, requires 46. 46 men, 70 kilometers, 28 days. The wheel existed in China in 1557. The Ming dynasty had carts, axles, and draft animals. They chose not to use them. For a 123-ton stone, the ice road was more efficient than any wheeled vehicle they had. The largest stone ever moved to the Forbidden City, the one called the Large Stone Carving, weighed over 300 tons. It arrived the same way. The same hidden logic. 6 civilizations, 6 continents, or close enough. Easter Island in the Pacific, Egypt along the Nile, the Inca in the Andes, Neolithic Britain, the Olmec lowlands of Mexico, Ming Dynasty China. They had no contact with each other, no shared language, no common religion that we know of, no trade routes connecting them. and every single one of them, when faced with the problem of moving a stone that weighed more than any animal could pull, arrived at the same answer: water, rope, coordinated human muscle, and a precise practical understanding of friction. The Egyptians poured water on sand, the Ming workers poured water on frozen ground, the Olmec used a river, the Moai walkers used the physics of a rocking base to minimize the contact surface. The Inca at Sacsayhuaman used 20,000 rotating laborers with thick leather and fiber cables, as recorded by Spanish chronicler Pedro Chiesa de Leon in 1553. The blocks at Sacsayhuaman exceed 120 tons. The joints between them are so tight that a knife blade cannot pass through. No iron tools, no wheels, no large draft animals. The biggest animal the Inca had was a llama, which can carry about 45 kilograms. That pattern, the same solution reached independently on 6 separate occasions across thousands of years, tells you something about physics. When the problem is the same and the available materials are the same, rope and water and coordinated human effort are not just one answer, they may be the only answer. But the pattern also has a limit, and that limit is still unresolved. The 2025 Easter Island study moved a 4.35-ton replica. The heaviest Moai ever raised to a platform weighed 86 tons. The Jehuti Hotep painting shows 172 men moving 60 tons, and the water-on-sand method has been confirmed in laboratory conditions. But no modern experiment has replicated a 120-ton Sacsayhuaman block being moved up a mountain. No one has floated a 44-ton Olmec head down a river and landed it safely. No confirmed ancient record describes the erection of the largest Egyptian obelisks step by step from the quarry to the standing position. The method is known. The physics is proven at small and medium scale. The full weight replication has not been done. There are 2 ways to read that gap. The first, the method scales, rope and water, and enough people work at any weight. And the only reason we haven't proved it is that nobody has tried at full scale in a controlled experiment. The second, there is something else, something in the organization, the tooling, or the technique that the surviving evidence doesn't capture. Something that explains how a 120-ton block was not just moved but placed with a precision that still defeats modern engineers trying to replicate it. The unfinished obelisk at Aswan is still lying in its quarry. The joints at Sacsayhuaman are still too tight for a knife blade. The Stonehenge bluestones are still standing on Salisbury Plain, 200 kilometers from the quarry where they were cut. The method that put them there is either fully explained and just awaiting a large-scale test, or it is still partly hidden, waiting in a document nobody has translated yet, or a quarry nobody has excavated yet, or a tool that decomposed long before anyone thought to look for it. So here is the question this evidence leaves open. Do these 6 civilizations converge on the same solution because physics leaves only one answer? And any intelligent people working with rope and stone and water will eventually find it? Or is there something else, a connection, a transmission of knowledge we haven't found evidence for yet, that explains why the answer looks so similar across cultures that had no known contact? I read every single one. The Inca answer. Return to Sacsayhuaman for a moment, because the numbers there deserve more than a passing mention. The fortress sits above Cusco at an elevation of 3,701 meters. The air is thin, the terrain is steep, and the blocks that make up its 3 massive zigzag terraces were not quarried on site. The closest quarry for the largest stones is several kilometers away downhill, which means the workers were not just moving 120-ton blocks across flat ground. They were moving them uphill at altitude to a precise final position where they would be fitted against neighboring stones with tolerances that a modern stonemason would struggle to achieve with power tools. Pedro Chiesa de Leon wrote his account in 1553, within living memory of the Inca Empire's collapse. He was specific: 4,000 men quarrying, 6,000 hauling with massive leather and fiber cables, the rest managing foundations and woodwork, 20,000 total, rotating in shifts. That rotation detail matters. It means the Inca understood that sustained force over time is more efficient than maximum force in short bursts. They were not just managing stone, they were managing human energy as a resource. The Inca had no iron tools. The hardest cutting implements they had were made from bronze, stone, and bone. No wheel, no large draft animal. The llama was their beast of burden, and a llama carries 45 kilograms on a good day. A single Sacsayhuaman block outweighs a llama's carrying capacity by roughly 2,666 times. And yet the blocks arrived, and yet they were fitted. The joint between two neighboring stones at Sacsayhuaman is not just tight, it is shaped. Each stone's face is slightly curved, so the contact point is a precise convex to concave match. That fit was not achieved by accident. It was achieved by a process of trial fitting, marking, removing, grinding, and refitting that required extraordinary patience and an equally extraordinary ability to move a 120-ton stone backward and forward by small increments to test the fit. No one has fully explained how that incremental adjustment was done. The stones are too heavy for any number of men to nudge by hand. The ropes and levers that moved them across kilometers would have been too coarse for millimeter-level adjustments. Something bridged that gap. What it was is not recorded in any source that has survived. The water secret hidden in plain sight, it keeps coming back to water. That is the thing that cuts across every civilization in this story. Not rope, though rope is everywhere. Not ramps, though ramps appear in Egypt and probably elsewhere. Water. The Egyptians poured it on sand. The Ming workers froze it into roads. The Olmec rode it on rivers. The Easter Island builders used the physics of a rocking contact point, which is a way of managing the same friction problem without adding a liquid, by reducing the surface area touching the ground at any one moment. Friction is the enemy. Water is the answer to friction. Every civilization that moved massive stones at scale discovered this independently. And the discovery was not written down as a principle. It was embedded in practice. In the jar, the worker carries in the Jehutiotep painting. In the wells dug every 500 meters along the Ming Ice Road. In the choice to drag an Olmec basalt boulder to the nearest river rather than all the way overland. The Jehutihotep painting is the clearest example of how long it took modern observers to see what was in front of them. That painting has been known to Egyptologists since the 19th century. The jar-pouring worker is visible in every reproduction. For most of a century, the interpretation was ceremonial, ritual, symbolic. Daniel Bonn at the University of Amsterdam ran the experiment in 2014. He built a small-scale sledge. He put it on dry sand. He measured the force needed to pull it. Then he added water to the sand at the front of the sledge, just as the painting shows, and measured again. The force dropped by more than half. The optimal water content, the amount that produces maximum stiffening and minimum friction, is a narrow band. Too little and it doesn't help. Too much and the sand becomes mud and the friction rises again. The Egyptian worker with the jar was not performing a ritual. He was calibrating. He was hitting a precise moisture level in the sand ahead of a 60-ton load by eye, by experience, by a knowledge passed down through generations of workers who moved heavy things across desert for a living. That knowledge was so embedded in practice that nobody thought to write it down as engineering. They painted it on a tomb wall as a record of what happened, and for 3,900 years, observers with no practical experience of moving heavy stones across sand looked at it and saw ceremony. The question of scale. Every confirmed experiment in this story has a ceiling, and the ceiling is always below the heaviest stones. The 2025 Easter Island study, 4.35 tons. The heaviest moved Moai. 86 tons. The Jehutihotep painting, 60 tons with 172 men, confirmed by laboratory friction analysis but not replicated in the field at that weight. The Ming Ice Road document, 123 tons, with the physics confirmed by Lee and Stone's 2013 PNAS calculations, but not replicated physically in a modern experiment. Sacsayhuaman, 120 plus tons, with no confirmed modern replication of the transport or the precision fitting. That gap between what has been tested and what was actually achieved is not a small one. It is not the kind of gap that disappears when you simply add more rope and more people. At a certain weight, the physics of rope and human muscle runs into hard limits. Rope breaks, people cannot sustain the force needed. The coordination problem becomes exponentially harder as the load increases. There is a credible argument made by several engineers who have studied these sites that the method scales, that the same principles of water lubrication, rope, and coordinated labor that work at 4 tons work at 120 tons, just with more people and thicker rope and more careful management. The Inca had 20,000 workers. If you have enough people pulling in the right direction with the right lubrication, the physics does not change. Only the numbers do. There is also a credible counter-argument that the precision fitting at Sacsayhuaman, the curved joint surfaces, the millimeter tolerances, requires a level of incremental control that no known rope and lever system can provide at that weight. That the erection of the largest Egyptian obelisks, some exceeding 300 tons when you include the base, involves a tipping and standing sequence that no engineer has successfully reverse-engineered from the available evidence. That the problem is not just moving the stone but placing it, and placing it is a different and harder problem than moving it. Both arguments are serious. Neither has been settled by experiment. What the stones remember. There is something worth sitting with here, beyond the engineering. The unfinished obelisk at Aswan is 3,500 years old. The pounding ball marks on its surface are still sharp. You can put your hand in them. The workers who made those marks were using a tool that is essentially a large round rock, and they were striking it against granite over and over to cut a shape that would eventually weigh 1,168 tons. They knew before they started that the stone would need to travel from Aswan to a temple site, probably at Karnak or Luxor, hundreds of kilometers away. They knew it would need to be raised to vertical at the end of that journey. They knew all of that, and they started cutting anyway. The stone wedges at Craig Rossi Feline in Wales were left in the quarry face. They are still there, geochemically distinct from the surrounding rock, brought to the site by Neolithic people who had a specific stone in mind from a specific formation for a specific purpose 200 kilometers away. Those people did not have a map, they did not have a written plan, they had knowledge of the landscape, knowledge of the stone, and a destination that was already under construction when they arrived at the quarry face. The 17 Olmec colossal heads at San Lorenzo were moved across 80 kilometers of tropical lowland and then, centuries later, deliberately smashed. The faces were carved with individual features. Each head is a portrait, not a type. Someone moved a 44-ton block of basalt across a river system to carve a specific person's face into it, and then someone else, centuries later, decided that face needed to be destroyed. The engineering that moved the stone survives in the landscape. The reason for the destruction does not survive anywhere. These are not just engineering problems. They are records of decisions made by people who understood their materials, their landscape, and their limits better than any modern observer has yet fully reconstructed. The engineering is the visible part, the decision-making, the planning horizon, the organizational structure that put 20,000 people on a hillside above Cusco and kept them coordinated across years of construction. That part is mostly gone. What remains is the stone, And the stone is very specific about what it remembers. It remembers the tool marks. It remembers the joint angles. It remembers the road it was built to travel on. It does not remember the name of the person who designed the road, or the system that fed and housed the workers, or the argument that was made to convince a community to spend decades moving rocks up a mountain. The last unanswered question. The physics is solved at small scale. The historical record is richer than it has ever been. Updated as recently as July and October of 2025, with peer-reviewed geochemical and biomechanical confirmation of methods that were previously theoretical. The pattern across 6 civilizations is clear and consistent. Water, rope, human coordination, and a deep practical knowledge of friction are sufficient to explain every case in this story at the weights that have been experimentally confirmed. What is not confirmed is whether they are sufficient at the weights that were actually achieved. The 86-ton Moai, the 120-ton Sacsayhuaman block, the 300-ton large stone carving at the Forbidden City, the largest Egyptian obelisks. Those numbers sit above every controlled experiment that has been run, and they sit there quietly, not demanding an alternative explanation, but not permitting a fully closed one either. The unfinished obelisk is still in its quarry at Aswan. The knife blade still cannot pass between the stones at Sacsayhuaman. The Stonehenge bluestones are still standing 200 kilometers from where they were cut. The Olmec heads are still in the ground at San Lorenzo, some of them still buried, faces that have not been seen since 900 BC. The method that put them there is either fully understood and awaiting a large-scale test that nobody has yet funded or attempted, or it contains something still hidden, in a document not yet translated, a quarry not yet excavated, a tool that decomposed before anyone thought to look for it. So the question this evidence leaves standing is the same one it has always been. Do these 6 civilizations arrive at the same answer because physics is the same everywhere? And any people working with stone and rope and water long enough will find the one solution that works. Or is there a connection, a transmission of knowledge across distances and centuries that the current evidence does not capture? That explains why the answer looks so similar in places that had no known contact. The stones are not saying, "Not yet. I read every single one.